Hi! Our last contests are over, and contests always means a very stressful time for our radios. And you can guess what happened. So we have blown radios. And here on the bench we have a Yaesu FT-1000, and we have a blown receiver due to the fact that too much power gets directly into the receiver. So that means we need to fix this radio, because we want to have it back for the next contest. So let's crack it open and see what's happened to the receiver signal path, and yeah, let's see that we can really fix it very soon, that it is back to our contest station when it is needed. Okay, and here is a proof. So I'm feeding in minus 73 dBm, so that should be an S9 reading, and yeah, we have really nothing here on our S meter, and yeah, only static, so nothing, no signal. So I go now and feed in minus 40 dBm, and yeah, so that is 30 dB more signal strength, and now you hear it is there, but with a very bad signal to noise. So let me go up to minus 20, which is really a huge signal. So that is 50 dB over S9, and you see we only get it is not already S3, so that is definitely the proof that we have a deaf receiver. And yeah, so what we can check is if the attenuator here is working, and yeah, so I can see that the signal goes down by it is 4 dB, for up to 5 dB, and that is another 6 dB. So that is working. So the internal attenuator is still working. So I believe that everything is good until this point. Yeah, let's crack it open and let's see where we have the problem. Okay, so we need to get access to our RF board, and our RF board is down below the power amplifier. So we need to get the power amplifier off, and then we should have access to our RF board, and then we can do our first tests. Okay, and here we are down at our RF board. So our signal directly here from our antenna input, and of course through our so-called antenna unit, which is down here, right? So there will be a link directly from this antenna unit through the filter board down to the RF board, and that means the first check we can do is simply a resistant or continuity test. So we simply set our ohm meter to the beeper, and let me see that I have here the right probes. Okay, so we set it to the beeper like so, and then I put one end into the antenna connector, and I'm pulling this little cable down here, because this is the link which is switched through. Yeah, and as you can already hear, so there is no attenuation. So that means this is good. So the signal up to this point will be without attenuation. Okay, so then we need to check where the signal goes first, and where we have our first diode. So that will be at least our suspect area, right? So let us see what we can find in our service manual, and then we decide where to go ahead. Okay, so this here is our RF unit, but we want to zoom in, and as you may see here, this is the input where we just tested if there is attenuation, and then the signal is here going through this relays, and here this is the attenuator stage. So it is our 6 and 12 and 18 dB attenuation if there is not the bypass through this relays. So altogether this is 18 dB, and then if we go ahead, so let me zoom in a little bit more so that we clearly can see it. So we can come out here. So again, this is the attenuation stage, and then we finally come here to our first diode, which we have here. So it is a 1055 and the 1056. And well, what we want to do right now is we want to check if there is a bias voltage available for these diodes, because as you may imagine, we need a bias voltage to be able to send HF through the signal path, and therefore that will be the first we do. We look out for the 1056 and for the 1055, and we check for bias. And knowing that, we can test with injected signal if we can get somewhere here a good signal. So that will be next. Okay, and this here is our board layout, and we have here our both diodes which we were looking for. So this here is a 1055, and this down here is a 1056. And well, if we go down to our board, that means, so let me see if I'm able to zoom in. Alright, so down here we have our 1055 and this little puppy down there, so that is our 1056. And yeah, as I already said, what I want to check right now is if we have any bias available at the diodes. And yeah, therefore let me check the 1056, which is the little SMD part. Let me see. It is a little bit difficult from here. So are you able to see anything? I don't know right now. Let me see. Okay. So down here we should read a bias voltage once again, and I'm reading nothing. Maybe it is a good idea to switch on the radio. Okay, radio is on once again. Now let me check for bias, which should be there. And okay, so let me see if I can show it to you. 1 second. Where's my meter? There. So that is the bias voltage at the anode, which is suspect. So let me check it on the cathode as well. And hang on, so this is a little bit okay. Let me go back to the meter. Yeah, so you can see the meter again. So this here is the anode, and there is a bias voltage, but at the cathode there is nothing, and that is not normal, considering that there is only a 100 ohm resistor behind this diode, so we should have a reading as well here at the cathode, but we do not have, and that is you know, really suspect. But anyway, biasing is there, and therefore we can be sure that nothing is wrong with the DC power supply for supplying this signal diode, so that is good. But yeah, as I said, so that looks a little bit suspect to me. That is not good. Okay. Okay, so next step is we are injecting a signal, and yeah, you can see it down there with my generator. So are we able to read something? Yeah, so you can see I'm injecting minus 72 dBm, which should be S9, and that is what I want to inject to this little diode. So first of all, of course, at the input, because that is interesting, and the input is the let me double check, it's the cathode side, of course, which is here. So here is the input, so I'm now injecting my minus 72 yeah, 72, but that doesn't matter, which should result into you know, S9 signal, and as you can hear, nothing, so no reaction. And well, so with the biasing it was already suspect, and well, with the signal injected to this point, nothing. Okay, so then let's go to the output, and that is then of course into the yeah, the further signal path, let me call it that way. So that is then behind this diode. And that is, yeah, that is really nice. So that seems that we already really have our problem. So that means, let me go to the meter over there, and the meter in the right one on the down one on the right side is our signal to noise meter, and let me inject my minus 72 signal, and you can see that we have a signal to noise of about 43 dB, which is phenomenal. So that is absolutely okay. And on the other hand, let's check what our S meter is telling us. Okay, so first of all I go again to the input of this diode, and yeah, I'm now at the input, and we do not hear any tone, and we do not see nothing. And now I change to the output of this diode, and as we know, we have a signal, we have heard it before, and we know it is a signal to noise of about 43 dB, and you see a nice S9 reading. So that means that is definitely our dead component. So what we need to do is changing this component, and then the receiver should be back to life. Okay, so my spare parts has been delivered, so I can now go and fix the radio, but therefore I have to take out the RF board here from the chassis, because otherwise I have no chance to go down to the component and yeah, solder it out to fix it. So that will be next. I go and take now the board out. Okay, so our RF board is out, and yeah, here is the chassis. So now I can desolder the defective component, and I'm gonna replace it, and then we hope that it will work again. Yeah, that is really not simple. It is all very close together, so we really have to be careful not to damage components around the one we need to replace. So therefore it is not possible to do it under camera, and yeah, for the moment in time, of course, it is not hot because I've just tested how I can get to the faulty one, and yeah, it is really close, so I'm gonna do it off camera. Alright, here is our diode. Down there it was, and now it is out, ready for replacing a new one. Yeah, might be interesting to double check it here with the meter. So the DMM is set to diode test, and if the diode is you really can only barely see it down here, so small it is. Yeah, so the multimeter is set to diode test, and when I'm yeah, it is so small and I can't see nothing here. So normally you would hear a beep if the diode would be okay, because it is set to automatic diode test, and well, that is very handy, especially if you have components like this, so tiny that you really have problems to get your tips to, you know, the contacts. Oops, and now it is gone. So it goes. No chance. Can I find it back? I'm lucky. Oh. Yeah, you see, that is the problem with SMD components. So yeah, I'm really in trouble doing it here through the camera. That is really a pain. But I just want to check, double check if we have really a dead diode. But as you can see, I have no chance to do it here through the camera. So last try, if it does not work, I have to stop, because that does not make any sense. But yeah, believe me, no chance. Okay, now I have contact, and yeah, no reaction. So that means, how do you call it? It is open. For me it is a little bit confusing. So that means no community, so that means high resistance. So yeah, no, at least a high resistor, so no current can go through. So this definitely, this diode definitely is dead, and yeah, that is the reason. A little pin diode. Okay, so as I already said down here, no, you can't see it. Here I have some new, and yeah, now we go and replace a new diode into the signal path, and then, well, I have a good feeling. So then radio should work again. All right. Okay, so our new diode is in down there, so very nice. Board has been cleaned, so there is still a little bit flux X on the board and the component. Yeah, so this is really a critical area to replace a component. So I only can suggest that you should not try such repairs if you are not really familiar with SMD solder work, and if you do not have really soldering experience, because you really can damage more you can imagine right now these components are really tiny, and the place here, so all is very narrow due to this relays, and therefore be careful, you really can damage more you ever would like. Alright, so our board has now to go back into the chassis, and all connections need to be put back in the right position, and well, then we are ready to do our first test. So all is back in place, and radio should work. So let's go for our first check. Okay, so let's switch on the radio. Okay, it is on the 40 meter band, and yeah, I've already hooked on the radio tester, and yeah, so let's feed in a signal that we can see what's gonna happen. And yeah, here we are. So the radio is back alive. So that is really nice. So I'm feeding in minus 73 dBm, and yeah, that all is looking pretty nice, so no problem. And I really have a nice and stable signal. So let's see if we can check it on the tester. So let's see. Alright, so that should be good. Yeah, so you really can see we have a nice, really a nice signal. We have a signal to noise of about 42 dB, which is more than good, and we have a nice and clear sign. So I have some reflections on the meter, so let me try to get it a bit better. Okay, so maybe that is a bit better. I know there are still reflections, so sorry for that. But meanwhile, I prepared the tester for sensitivity test, and as I can find in the specifications of this radio, we should be able to read 10 dB signal to noise with an input level of 0.16 microvolt. So that means 160 nanovolt. And what you can see, so the generator is already adjusted to 0.160 microvolt. So that's the reason why I changed the setting to microvolt, because that is what is set in the spec. And yeah, what can we see? Here we see our sinus value, and you see, yeah, it is jumping, but that is normal. So if you can see a little bit the screen, let me see, is that better? No. There we have another reflection, so that is really a pain here. Not much better, but maybe a bit. So you can see it is a noisy signal, so that is clear. I mean, can we hear it on the speaker? Not really. Let me try. You can hear the tone is still there, but remember, we are only sending with 160 nanovolt, and that is extremely low. And you can see on the other hand that we are really meeting the specs of Yaesu itself. So that generally means it is not only a repair, it is also a repair which brings the radio back to the original specs. So that means radio is really sensitive and everything is fine. Okay, so then let's go ahead. Alright, so we know that our receiver is really in a good shape right now, so the sensitivity is more than good, everything is fine. So I'm gonna back and put now our PA unit back to the chassis, and of course our fan, and so yeah, let me bring it all back in position, and then we can go ahead. Okay, so everything is back together, very nice. Radio still receiving. So, very good. Then let's go ahead. Okay, so the contest crew asked me to check the local oscillator frequencies and the master crystal to be sure that the radio is really on frequency. And yeah, therefore I have already here on the screen our alignment procedure, and so I will now follow the alignment procedure, and let's see if all the specs are given, or if we have to, you know, trim it a little bit to the right frequency. Okay, so I'm here on the RX2 unit, and I'm checking the second oscillator, and second oscillator should be 46.755 megahertz, and yeah, if we see the reading on our counter, it is not 755, so we have a delta of you know, what is it, 450. Well, so let me adjust it that we really can get to 755, and yeah, here we are. It is already going into the right direction. So we are looking for 755. Okay, so very slow. We have to go very slow to meet at least our 755. Here we are. Here we are. So the last digit is not the problem. Yeah, but you see, it is exactly now on 46.755. Last digit is jumping, but last digit right now means that is 1 Hertz. And yeah, we have a couple of 100 Hertz, which it could be wrong. But I see it is really sensitive. It is really, you have to do it really slowly not to miss the right point. But now the second oscillator is definitely on the right frequency. So that is good. So I will do some more test points to be sure that all the different frequencies are on the right setting, and so that it will take a while, and to be honest, you know, that is really boring, so I don't do it on camera. So you have seen how it basically works. So this here was a little transformer. I was turning for our second LO frequency, and as you have seen it on the counter, it is now fully aligned, and now I go ahead, but yeah, it does not make any sense to do it all on camera because it really takes much too long, and so then that is getting boring. So let me go ahead and I'll let you know the result. Well, for the moment in time, I'm here on the reference ref unit, and the ref unit is, if you like, the master crystal. In this case it is a TCXO. So normally following the alignment procedure of Yaesu, it is not foreseen to align this TCXO, but they are asking for confirming a delta of maximum 5 Hertz. But in this case the delta is 10 up to 15 Hertz, and normally you are really not able to align a TCXO, but there is always, as you might see it, let me see if I can go a little closer. So there is always here a little pot inside, so that is you know, to align the delta, and that is a very little area where you can adjust it into the right way. So yeah, you know, as I said, it is not foreseen in the alignment procedure, but as long I'm sure that my counter is really spot on, I can try and tweak this here a little bit, and I will then show you the result, because I just want, you know, the reference board really spot on, because all the other frequencies are coming or depending, so that is better say, depending on the master crystal. So let me try to get this more in spec. Okay, and now I have adjusted a little bit and yeah, see the result. So that is much better than what we had before. So yeah, the requested frequency is really 485 10.485760, and the allowed delta is 5 Hertz. So the last digit you can see is 1 Hertz, and you see it is yeah, jumping maybe 1 Hertz, but basically it is now much better. So the first time when I wanted to confirm, you know, this frequency, we were 15 Hertz off, and as I said, allowed is 5 Hertz. So for me that was too much, and now it is really nice in spec, and that is from my point of view very much important, because this is the master reference. So that is a master crystal, and that should be really spot on. And that's the reason why I wanted to show you this procedure. Also, it is not mentioned and foreseen in the service manual. Alright, so the ref unit is back in place, and now I can really confirm the frequency. The master frequency is 10485760, and that is what we can confirm right now. So that is what we want to see. Okay, so what you can see here is, of course, the big letters are the generator frequency, but the smaller display down there, you can see it is jumping a little bit, and that is our audio frequency, which is feedback to the tester. So that means the radio is now exactly on 7.1, and it is of course SSB, lower sideband, so that's the reason why our generator is set to 7.099, because we need our 1 kilohertz audio frequency, and now the radio should receive this 1 kilohertz tone, which is this one here, what you can hear, right? And yeah, I go back on dummy. And for us, it is absolutely important to have it on frequency, because that is telling us that all the oscillators in the radio are now really aligned to the right value, because otherwise the radio would not give back our 1 kilohertz tone. But it is doing that, and we have here a very nice sign. So that is our audio frequency, which comes back from the radio, and that is a respective frequency, and that means, yeah, our radio is exactly on frequency. Alright, so that means this repair is done, and yeah, I have to put back the last, yeah, the speaker needs to go back in its position, and of course then I have to put back the housing and so on. But our repair is done, so we have back a nice transceiver which is receiving really good. Everything is fine, and we did the alignments for having the radio really spot on frequency, so that is done as well. Okay, so this radio can go back to our contest crew, and yeah, so next contests can come. Alright, so that's it. Thank you very much for watching, and if you like this video, please give me a big thumb up, and yeah, again, thank you, and catch you next time. Bye.